Hello everybody, welcome to another episode of Master the NEC, where we talk about the National Electrical Code. My name is Paul Abernathy, your host, and welcome to today's video and podcast. Now, today we're going to talk about one little component that we would use in a commercial calculation. Now, the reason we're saying commercial is because under dwelling units in 1 and 2 family or even multifamily, when you're talking about the general lighting loads, you're also going to encompass the general use receptacles within part of that calculation when we're using the actual VA per square foot under table 220.12. But when you're talking about a commercial building and we're trying to do some calculations, then we're going to treat the receptacles differently and we're going to calculate the general lighting separately. So in our example today, we're going to talk about one little element, and that little element is how do we deal with fixed multi-outlet assemblies. They're very common in stores and things like that, where you'll have this kind of like a strip molding, if you will, and it's got the receptacles built into it. They're fixed multi-outlet assemblies with the single receptacles that are located in it, and it can be in any various lengths, whether it's continuous or separated. And you need to know how to calculate these. So what we're going to do today is try to get rid of the confusion that people have when it comes to receptacles. And most notably today, we're going to talk fixed multi-outlet assemblies. Now, if you're not familiar with what these are, you can do a quick Google search and just type in fixed multi-outlet assemblies and then do the images under Google search, and you'll see all different types. It's almost like a plug mold, if you will, with the receptacles in it, and it can have any number of receptacles per feet, every 6 inches. It doesn't matter. But when we're doing the calculation, we're set with some very specific parameters that we have to follow. And I want you to be sure that you know how to do this when you get an exam. So here we are in the National Electrical Code. As you can see, I've got it on the screen. And we're going to be dealing with multi-outlet assemblies. Okay? Now, in these multi-outlet assemblies, we're going to learn how to calculate these. Now, we're going to read this code wording here so we have a better understanding of what we're dealing with in the scope of these multi-outlet assemblies. Okay, and I guess I can try this real quick. Let me go right here and see if I can't find. I'll do this for you. That way people that are confused and you can't see all of my screen, that's perfectly fine. I just want you to see the most important part. And let's see here. Too many W's there. Okay, hold on. www.google.com. And let's see what we got. And I'm going to type in here let's do it so I can show you. Multi-outlet assemblies. And we'll just see what it is if you can get some pictures of it. Let's do some images. Okay. So multi-outlet assembly, here's a good example of one right here. Here's a good example of how you'd see them. And this is some calculations that are done by a well-known dude I know. And here you go. Here's some multi-outlet assembly right here. You see it's got multiple outlets, assemblies. They're receptacle, all. And then, of course, you have the chase, and all the wiring is located inside of this track. Let's see here if I can get another image of. There's an example of a multi-outlet assembly. There's an example of a multi-outlet assembly. Okay? All right, so now we've got a full understanding of what a multi-outlet assembly looks like. Okay, let's calculate it out. Now, first thing, let's give you a scenario. And so that you can understand how to apply this. So let's say that we have 65 feet, okay, of multi-outlet assembly. This fixed multi means you're going to mount it. And it's 65 feet, and it is, in this case, it is likely to be used simultaneously. So, I mean, any one of those receptacles could be used, okay, at any given time simultaneously, okay? All right, and then, of course, the next one we have 50 feet that are not likely to be used simultaneously. Okay, they're just at random. Okay, only you're going to know which is which, and if you're taking an exam, they're going to tell you whether or not to consider it simultaneous use or not simultaneous use. Okay, so let's take what we've learned here. Our examples: we've got 65 feet that will be used simultaneously, and then you've got 50 feet that will not be used simultaneously. All right, so let's read the code really quickly so we understand it. It says, fixed multi-outlet assemblies used in other than dwelling units or the guest rooms and guest suites of hotels and motels shall be calculated in accordance with H1 or H2. That's to remind you guys that when you're doing dwelling units and you're doing guest rooms and guest suites, those general receptacles that are in there are already factored in to the general lighting load is because, as we see over here in 220.12, when you're looking at things like dwelling units, you have this little A right there. And so that's 3 VA per square foot for the lighting. But if you go down here, you'll look at the A reminds us to look at J. And J is what tells you that, look, in one family, two family, multifamily, guest room, guest suites, and whatnot, general use receptacles are already figured into the load calculation. So I don't have to do anything extra. Now remember, if there's a dedicated circuit or an individual brand circuit to a specific receptacle that's not one of the general purpose ones, and there's a specific load on it, then you'd have to account for that. But these are all our general purpose receptacles, okay? So you don't really have to consider anything differently. Now, for us anyway, when we're dealing with a commercial building, that's not the case. So we have to look at H1 and H2 right here. All right, so we have two conditions that we want to be aware of. The first one, we had 65 feet of fixed multi-outlet assembly that was used simultaneously, so that's right here, that is likely to be used simultaneously. And then we had 50 feet that is unlikely to be used simultaneously. All right, now first thing, let's remember a couple things. Even in this 50-foot piece, or even this 65-foot piece, I could have any number of receptacles on there, okay? This is a calculation. Don't confuse it with me having to have one receptacle every foot in the ones that are likely to be used. This is just a calculation for you to be able to calculate the actual VA, okay, when you're doing a load calc. Okay, so don't consider this as telling me how many receptacles I have to have. This is simply for load calculations, okay? All right, now, it says, for the purpose of this section, the calculation shall be permitted to be based on the portion that contains receptacle outlets, okay? So for this calculation, we're dealing it on the portion that actually contains it, not the portion that might be just a chase that doesn't have receptacles, okay? All right. First one, let's deal with this one and knock it out of the way. Where appliances are likely to be used simultaneously, each 5 foot or fraction thereof of each separate and continuous length shall be considered as one outlet of not less than 180 VA. Okay, so let's break this down. Each 5 feet, of course, in our case, this first one, unlikely to be used. We had 50 feet. But what is this fraction thereof? Well, that just goes to say, if I don't have a 5-foot piece, let's say I've got a 4-foot piece. Well, that's still a fraction of the 5 foot, so it still would be counted as 180 VA, even if it wasn't a full 5 feet. So what if it was 8 feet? So if it's 8 feet, then the 5 foot would count as the one, and then the fraction thereof would be whatever remaining up to the 5 feet. So if it was 8 feet, it would still be 180 and 180. Okay, there's two 180s. Okay, so that's kind of tells you how that works. Of course, if I had two 5-foot pieces and it was 10 foot long, then it would be 180 for the first 5 feet, 180 for the next 5 feet. Okay, all right. So let's kind of do some math in ours. So let's deal with the ones that are unlikely to be used, and that was our 50-foot length. Well, since we're trying to break it down to every 5 feet, then we're going to go 50, because that was our value, divided by 5, because that's going to give us the number that we're going to multiply by the 180. Gives us the number of 5-foot sections, if you will. So we go 50 divided by 5 equals 10. Now, there's 10 5-foot sections in 50 feet. So we're going to do 10 times 180, because that's what it says to do right here. And that's going to be 1,800 VA. So you write that down. So that's the VA for the portion that is unlikely to be used simultaneously. Now, let's go to the next one. So now we know we had 65 feet that was likely to be used simultaneously. Okay. Well, in this one it says, where appliances are likely to be used simultaneously, and an exam's got to tell you that, okay? It's not something like on an exam that you've got to guess at. They either have to, because of the way the nature of this calculation works, they have to either tell you it's simultaneous use or not simultaneous use, okay? So it says, where appliances are likely to be used simultaneously, each 1 foot or fraction thereof, and it applies the same way. If it was 1.5 feet, the half foot is a fraction thereof. So 1 foot would be 180, and that additional half of a foot would still be another 180. Okay? So it says, where appliances are likely to be used simultaneously, each 1 foot or fraction thereof shall be considered as an outlet of not less than 180 VA. All right, so let's do this math. Well, we knew it was 65 feet. So with it 65 feet, that one's pretty easy. It's 180 VA, it's 1 foot, so we know that there's 65 1-foot sections in there, if you will. So it's 65 times 180, and that equals 11,700 VA. Okay, so if you were taking the exam and you wanted to know what the connected load was, then it would be 11,700 plus the 1,800 VA. Okay, so that's a total of 13,500 VA. But we're asked for the connected versus the calculated, then we would be okay with the 13,500. But we get asked all the time, what is the demand load or what is the calculated load? If that's the point, then we know that there's another step. Well, since this is a commercial application and we're over 10,000 VA, then you got to go all the way down here and we get to use some demands. Okay, check it out. Since it's a non-dwelling receptacle load, right there, we get to use 220.44. And 220.44, and if you go up and look at the actual code language, it'll tell you right here. It says other than dwelling units, because I can't use it on dwelling units. It says receptacle loads calculated in accordance with 220.14H and I shall be permitted to be made subject to the demand factors given in table 220.42 or table 220.44. Okay? All right, so in this case, what we're dealing with was, let's say, a store. So it's really not going to help us up here in 42, right? That's generally the lighting demand anyway. So that's not going to help us too much. So what we found is, since we're doing the calculations and we were using I, let's go back up to I, and excuse me, we're using H for fixed multi-outlet assemblies. And we just saw what it says down here in 44. Now we get to go down here, since we're just doing receptacles, okay? We're not even doing any full calculations or anything, okay? We're doing demand factors for non-dwelling receptacle loads. All right, so now it says what? The first 10,000 kVA or less at 100%. And then the remainder over 10,000 at 50%. Well, our total was 13,500. So we write down the 10,000 because that's 100%. We have to take the first 10,000 at 100%. So that part we're going to keep. Okay, that's our 10,000 VA or 10 kVA, whatever you want to say it. We keep in that. And I always tell people on exams, make sure you break it all the way down into the VA. So if it was 10 kVA, that's 10,000 VA. All right, so what's the remainder of our equation? Well, we had 13,500. We took 10 away from it. That leaves us with 3,500. Okay, well, the 3,500, we can apply a 50% demand factor to it, a percentage. So we do 3,500 times 50%, and that's 1,750. So we take that 1,750 and we add the 10,000 back to it. Remember, because we took that at the full 100% value. That gives us 11,750, and that is the calculated VA or demand load for the non-dwelling receptacle loads in our question. Because our question simply asks about fixed multi-outlet assemblies. Okay, so that on an exam, if you get that simple question, it asks you about the fixed multi-outlet assemblies. That's just simply how it works. Okay, well, that's just a short episode that talks about fixed multi-outlet assemblies. Hope you got something out of it. Until next time, stay safe, God bless, and thanks for watching our videos and our podcast. Until next time, stay safe.